explain how to find limits algebraically. These are the responses that you can have from a function, and they are: if you get a number, the response is a number. If you get a 0 over a number, it's 0. If you get a number over 0, it's positive or negative infinity, and 0 over 0 is undetermined and you have to do something. So in this example, if you put the 3 in the function of the example, you get 0 over 0, which means you have to do something. So what you have to do in this example is that you have to factorize first, and then so what I did was that I factorized the one in the top, so I get this, and you can cancel this with the one in the bottom. So now I have x plus 2. And if I substitute the 3 of my limit in this new function, I get. So from this, the answer you get is 5, which means the limit is 5.
We're going to find limits when f of x approaches infinity with complex rational functions. So this is the first example. And first you have to substitute 0 in the equation. So we have 2 over 0, and when it's 2 over 0, it's going to be plus minus infinity. And we have to do something. So the limit doesn't exist, so we have to see when x approaches 0. So the limit when x approaches 0 from the left is going to be and the answer is going to be 2.0004 over 0.000497. And since they are both positive, the answer is going to be positive infinity.
We're gonna find limits numerically. So in this example, we can know that if x approaches 1, we get 0 over 0, which is undefined. So what we're going to do, it's a graph. And we have to know which value approaches 0. So we graph the numbers near 1 from the left and from the right, and you get
0.9, 0.99, 1.01.
With this, you change the x to these values, and you get
2.71, 2.97, 3.003, 3.31.
So by this, you can calculate which is the limit of 1, which is almost 3.